I am Carter Baird, a graduate of the Holland College Bioscience Technology program, and this is my capstone independent research project, BactoSupreme versus New Microbial Media, Comparative Growth Study of Transformed DH5α E. coli Fermentation in Bioreactors. The economical production of mRNA vaccines became of worldwide importance with the global COVID-19 pandemic. And the first step in mRNA production is the production of plasmid DNA complementary to the mRNA via precision fermentation of transformed E. coli in bioreactors. Holland College was fortunate to acquire pre-transformed E. coli from BioVectra that produces the plasmid coding for the mRNA COVID vaccine. However, the recommended media for the bioreactors, BactoSupreme, is expensive at over $5,000 for 10 kilograms. We hypothesized that a novel and economical semi-defined medium, according to the literature, could be developed that was just as effective as BactoSupreme. Let's call it CB23. To show this, there were 3 steps. Step 1. Isolate the plasmid produced by these E. coli and confirm that it is the one BioVectra said it was. Step 2. Develop the CB23 media for ideal plasmid production. And Step 3. Measure the outputs from triplicate runs using BactoSupreme versus CB23 with equivalent bioreactor parameters for statistical comparison. Here we see the gene map of the plasmid to the left and an agarose gel evolution samples from the Genelute plasmid isolation kit to the right. To confirm presence of the plasmid expected, samples were subjected to restriction enzymes EcoR1 and EcoR1 with SCA1. Look closely at the map and you'll see that the plasmid is 6.6 kilobases long, which is confirmed in lane 4. Look closer, and you'll see that the fragments expected from exposure to EcoR1 and SCA1 are 4.7 and 1.8 kilobases long. These are confirmed by the 2 bands in lane 3. This confirms the presence of the plasmid. Lane 2 contains the eluate without any restriction enzymes, and here we see the same plasmid in 4 different configurations. The development of CB23 media consisted of a shaker flask fermentation study. From the literature, CB23 contained 10 grams per liter of glycerol and 20 grams per liter of yeast extract. You can see its color in a cuvette to the right. A slurry of trace elements was formulated, and 3 ratios of trace elements were tested for dry cell weight and DNA concentration in the eluent from the isolation kit. Since the 1:100 ratio yielded the greatest dry cell weight and the highest DNA concentration, this was the trace element dilution selected for CB23. Now to the overall method. A bioreactor was run at the same parameters listed with 3 vessels of BactoSupreme, and then a second run was completed with the same parameters using CB23. Here we see that 6 10 ml samples were taken from each vessel. 3 had their plasmid isolated with the Genelute kit and then measured on nanodrop, and 3 were centrifuged before the liquid was poured off and the pellet was dried in a low temperature oven overnight. The gravimetric difference between the test tube with the dry pellet and without gave the dry cell weight. Here are the t-test comparisons between the 2 media. The dry cell weights from BactoSupreme were significantly higher than CB23. However, the DNA concentration and specific yield had no significant difference between the 2 media. The higher cell weight shows that BactoSupreme to be a good and easy choice, especially in the beginning. However, that CB23 was able to overcome its cell deficiency to no significant difference elsewhere shows this is worth further study. There is potential to save money after the production process has been established.